Have you ever wondered what it actually takes to power artificial intelligence at scale? As AI models grow larger and more powerful, they're creating an unexpected problem behind the scenes, an energy crisis that few people are talking about. In this video, I'm going to break down the AI energy crisis, why training and running AI systems requires massive amounts of electricity, and what this means for data centers, power grids, and the future of technology. This challenge could shape how fast AI can really grow. Before we jump in, if you want clear insights into the hidden costs of emerging technology and where the future is headed, hit the like button, subscribe, and turn on the bell so you don't miss future videos. The hidden cost of AI. When you ask ChatGPT a question, it feels instant and effortless. But behind that simple conversation, thousands of computer chips are working at full speed inside massive data centers. These AI models are not just programs running on your laptop. They are enormous systems that require industrial-scale computing power. Training a single large AI model can consume as much electricity as 100 American homes use in an entire year, and that is just the training phase. Once these models go live and millions of people start using them every day, the energy demand skyrockets even higher. We are not talking about a few extra light bulbs. We are talking about power consumption that rivals entire cities. To put this in perspective, generating an AI image can use as much electricity as charging your smartphone. Writing a power graph with AI assistance might consume the same electricity as leaving your laptop on for an hour. Multiply that by billions of requests happening globally every single day, and you start to see the scale of the problem. The servers running these AI systems need to stay on constantly. They cannot be turned off at night or during slow periods. They require uninterrupted power supply, backup generators, and sophisticated cooling systems. Every component adds to the total energy bill. Data centers are taking over. AI data centers are popping up everywhere, and they're consuming electricity at an alarming rate. These buildings are packed with specialized chips called GPUs that generate enormous amounts of heat. To keep them cool, companies use massive air conditioning systems that run around the clock. Some facilities use more water for cooling than entire neighborhoods. In regions where data centers are concentrated, local power grids are struggling to keep up. Utility companies are warning that demand is growing faster than they can build new power plants. In some areas, energy officials are already sounding the alarm about potential blackouts during peak usage times. This is not a distant problem. It is happening in cities across America right now. Northern Virginia, home to the world's largest concentration of data centers, is facing a power crunch. Ireland had to pause new data center approvals because they were consuming too much of the national grid. Singapore banned new facilities for similar reasons. These are not small operations hidden in remote locations. They are massive industrial complexes, often built near cities where power infrastructure already exists. Each new AI data center that comes online adds pressure to an electrical system that was designed decades ago for a completely different world. The coal and gas comeback. Here's where things get awkward. Tech companies have spent years promising to go green and reduce their carbon footprints, but the explosive growth of AI is forcing them to make uncomfortable choices. Some are keeping old coal and natural gas power plants running longer than planned because they need the electricity immediately. Renewable energy sources like wind and solar cannot yet provide the constant, reliable power that AI data centers demand. Solar panels don't work at night, and wind turbines don't spin when the air is calm. Battery storage technology is improving, but is still not ready to support massive data centers for extended periods. So, despite all the talk about sustainability, AI companies are increasingly turning to fossil fuels to keep their systems running. Nuclear power makes a comeback. Faced with this energy crisis, tech giants are doing something unexpected. They're betting big on nuclear power. Microsoft recently signed a deal to restart a reactor at 3 Mile Island, the site of America's worst nuclear accident. Amazon and Google are investing billions in small modular reactors, a new type of nuclear technology that promises to be safer and more flexible than traditional plants. Why nuclear? because it provides massive amounts of electricity without burning fossil fuels, and it runs continuously regardless of weather conditions. Nuclear power plants can generate energy around the clock, making them perfect for data centers that never sleep. This marks a dramatic shift in how Silicon Valley thinks about energy. Just a decade ago, nuclear was seen as outdated and dangerous. Now it's being embraced as the only realistic solution to power the AI revolution without destroying the planet. These new small modular reactors can be built closer to where the power is needed, reducing transmission losses. They produce far less waste than older designs and have advanced safety features that make meltdowns nearly impossible. Some can even be mass-produced in factories and shipped to locations where they're needed. The real price of progress. This energy crisis raises serious questions about the future of AI development. Can we afford to keep building more powerful models if it means risking blackouts and environmental damage? Some experts are calling for efficiency improvements, pushing companies to design AI systems that use less energy. Others argue we should slow down AI development until our energy infrastructure catches up. But the companies racing to dominate AI are not waiting. They're signing deals, buying power plants, and building new data centers as fast as possible. The competition is too fierce, and the potential profits are too large. Meanwhile, ordinary people are left wondering if their electricity bills will skyrocket or if their lights will go out because tech companies are using all the power. This is not just about technology anymore. It's about priorities, resources, and who gets to decide how our limited energy supply is used. What happens next? The AI energy crisis is not going away. If anything, it's going to get worse before it gets better. More companies are launching AI products, more people are using them, and the models are getting bigger and more power-hungry with each new generation. Governments are starting to take notice. Some are offering incentives for companies to build energy-efficient data centers, while others are imposing restrictions on where new facilities can be built. Energy experts are racing to develop better cooling systems, more efficient chips, and smarter ways to manage power distribution. But the fundamental problem remains. We're asking our electrical grid to do something it was never designed to handle. Unless we make serious investments in new power generation and transmission infrastructure, we could face a future where AI advancement comes at the cost of reliable electricity for everyone else. The question is not whether AI will change our world. It already has. The question is whether we can power that change without breaking our entire energy system in the process. When you step back and look at it, the biggest limitation to AI may not be intelligence, but energy. How we solve this problem will determine whether AI remains sustainable or becomes too costly to scale. I'm curious, do you think technology will adapt fast enough to handle AI's energy demands, or are we heading toward real limits? Share your thoughts in the comments. These discussions help us think ahead. If this video helped you understand the unseen challenge behind AI's rapid growth, don't forget to like, subscribe, and share it with someone interested in the future of technology and infrastructure. Thanks for watching, and I'll see you in the next one.